I need to explain what I'm doing here. I'm recording from two different spots, and I want to make sure that I can synchronize them. That's why.
And this lets the genies know we're now beginning. It's a magical evening. Well, thank you all for coming, and again, thanks for the invitation to speak on Darwin's birthday. I should let you know, for those interested on the stage at the break, there are some commemorative coins that were given to me on Charles Darwin's 200th birthday. So if there's something that might interest you, you can take a look at them over there. And with tonight's talk, I'm going to be looking at human evolution and how it plays in with critical thinking, and then the concept of self. And these are all tied in to one another in a kind of a very interesting way. And so by way of introduction, there's a number of things to consider. I'm just going to move the computer. That's good. So we're going to look at human evolution, and my area of expertise is in what's called cognitive evolution, or how and when human brains got bigger and better and that sort of thing. Look at some of the selection pressures that led to the development of cognitive evolution. And they're calling what I do experimental philosophy. I didn't realize this is what I was doing back in 1998, but now they have a term for it, experimental philosophy. We just called ourselves philosophical anthropologists. But I'm very much concerned with what's known as the EEA, or the environment of evolutionary adaptiveness, and specifically a certain time period of the EEA. And we're also going to look a bit at the development of language and consciousness, and how logic and critical thinking might have evolved. So I have a number of interesting ideas on how I think those skills came to be. And this produced what I call a natural logic, which inevitably led to what we today would call critical thinking. So how all of this, through these millions of years, led to our greater understanding of the self, will kind of tie it all together. So you're in for a treat tonight. You get a lot for your time. So here's the EEA, and it's quite large. You can see it goes from 6 million years ago to 10,000 years ago. So it's a fairly large period of time, but I'm mostly interested in what's known as the Upper Pleistocene, or about the last 60,000 years or so. And I look at things like migratory patterns of our ancestors, what food was available, how animals were eaten and plants were eaten, and some of them went extinct and some of them survived. What was happening geographically, and in terms of climate changes, weather patterns, the last glacial maximum retreating roughly 20,000 years ago, the last ice age that we've experienced, things like tool use, artifact records, and then how we can see changes in how they lived kind of on a day-to-day basis in terms of scavenging and hunting and gathering. Physiological changes, including gene mutations, new faunal groups led to the accompaniment of encephalization, or brain size increase. And specifically, the anatomy or the physiology of the brain, which parts of the brain might have contributed to certain patterns of critical thinking, namely the prefrontal cortex. And then we see humans speciating around 200,000 years ago. So, the emergence of language and consciousness, as well as relevant neurobiological factors, these all play into it. So there's a lot of things that were happening during the time span of human evolution. Now here we can see where we go back to the Australopithecines, and we see the size of brain mass here, starting fairly small with about 450 cubic centimeters, and then moving into the Homo species, and then picking up and gaining considerably to about 1450, what we're now at. So fairly large encephalization occurring over the last, say, 4 to 5 million years in human evolution. And our dentition changed as well in terms of not just the type of teeth, but the shape of the mouth and whatnot. And these were all intimately connected to the types of things that we were eating and the way in which brain growth was taking place. Our guts shrunk as well because we went from a predominantly plant-based diet to a more meat or omnivorous diet. You may be vegetarians today or vegans today, but you have your ancestors, your meat-eating ancestors to thank for your brains getting this big. So without the meat, they could not have provided enough fuel for the brain. Brain is a very costly organ. About 20% of your body's energy goes into your brain. So in terms of evolution, we put a lot in terms of, we put a lot up for stake in terms of that one particular organ. Now here's Phil Lieberman's work with pharyngeal development. Humans are the only ape where our larynx drops 2 years after we're born. A gene kicks in and the larynx drops. So if you're wondering why newborns can suckle and continue to breathe, it's because their larynx is high and they can do circular breathing, right? Any trumpet player would love to just have that stay like that so that they could just carry a note forever and breathe through their nose, right? But they can't, it drops. That's why you can't breathe while you're drinking a glass of water. You don't have to try that to find out. But Phil Lieberman looked at all of the primates, all of the physiology of all the primates, and found that humans are the only ones that have this gene that kicks in. Well, the drop in the larynx allows for greater articulation of speech. Now, we have to be careful here. We can't just spin up a bunch of just-so stories. What we have to do is we have to look at all of the pieces of the puzzle together. But this is just one more, and a very important one as well, the physiology of our vocal tracts. And many believe that we were born to run. So here's Dan Lieberman, Phil's son, who's now at Harvard. And some of you might have read some of his work, I'm not sure. He believes, unquestionably, humans, when you look at our physiology, we were a running species. We didn't walk, we didn't hobble, we didn't roll around, we didn't crawl. We ran. And he's basically filmed Bushmen of the Kalahari running the wildebeest to death. Because they have to stop in order to cool, to breathe. And if you keep running them, they overheat, right? So when they overheat, they faint, they pass out, and then they're an easy target for the hunters. So when you look at Homo sapiens for the past 200,000 years, when you look at the muscles attached and the arch of the foot and the fact that we're one of the few, if not only apes that can rotate like this, that's pretty much, a good indication that those skills, those properties were used for survival. So by about 70 to 10,000 years ago, between those periods, our ancestors were pretty much like us. They were shorter, but they were pretty much like us. Brain size was roughly the same. So, we left Africa roughly around 60 to 100,000 years ago. This might be an ongoing changing thing. There might have been a first migration, I believe now a second migration that occurred. So, it's roughly around that period. We see lots of advanced stoneworking technology. And many of you will have already seen this, but I'll pass it around anyhow. So here's your typical hand axe that was used by our ancestors. And this was created by Dan Adler at Harvard when I was a postdoc there in the Stone Age lab. And he made this for our son Jeremy. And it's fascinating because, lots of work goes into, when they find hand axes now, they preserve them extremely well, and they ship them to places like Harvard and right to the Stone Age lab so that they can carefully unpack them. And then they go under very, very high-powered microscopes to look at the edges, to see what was last in there that these things might have been cutting. So it's interesting that it has a point, it has a blunt end, it has sharp edges, but the flakes are also extremely sharp. They're like razor blades. So they call this kind of like the Swiss Army knife of the prehistoric days. And we now have some indication that this was used to smash bone, because humans were the only animal that could get into the marrow of bones, which is very, very rich in protein. So quite a multi-purpose little device, and it remained unchanged for about 980,000 years. So no upgrades coming anytime soon. More and more sophisticated tools start to develop during this time period. Engravings, cave paintings, art, burial rituals we see for the first time, more sophisticated hunting and fishing techniques. And we know by their migration patterns that they followed rivers and they followed the ocean. So when they left Africa, they eventually made it through Malaysia. They made it walk to Australia because there was a lot more real estate, because there was an ice age. When you have an ice age, you have less water. And when you have what's going on today, you have more water. So they literally walked to Australia and then walked to the Americas. And then the last glacial maximum retreated, and then all of the Americas off limits. So, hominin physiology, we know brain encephalization, gut size, dentition, pharyngeal development, geographic changes, all these different factors here. Genetic mutations, humans, unlike any other ape, have what's called the FOXP2 gene discovered by Klein. What this is it kicks in, the gene kicks in at a particular time, which allows for the greater facilitation of hearing sounds and articulating and enunciating. So it's not just one thing, it's not just the drop of the larynx, it's not just becoming bipedal and walking on 2 feet, it's not just moving around, it's all of these things that came together, right? Mostly moving around in small kin-based nomadic groups, and lots of room for development in terms of these new brains and the development of symbolic thought, right? So I call this kind of a perfect storm of evolved traits and characteristics, both behavioral and physiological. So bipedalism, walking on 2 feet, the change of diet, becoming omnivorous, lots more meat, the brain's growing, the pharyngeal development, the dentition changes, migratory patterns, and the coevolution of language and consciousness became an extremely important aspect. This guy, anybody who took philosophy, Ludwig Wittgenstein, he once famously said, "The limits of my language mean the limits of my world." He was an analytic philosopher and meant something quite different in the Tractatus Logico Philosophicus, but he's dead on in terms of describing how our ancestors would have functioned within their world. Language is a tool. It has syntax and socialization, intelligence, creativity. And these create what Dawkins called memes. It's a very handy term to just mean anything that is culturally invented. Anything, even beliefs in God, right? Any particular information. We can just refer to those as memes. And so the real cultural explosion, when we look at the artifact records, occurred roughly around 40 to 50,000 years ago. That's where we see things really starting to take off. And what this indicates to me and to a group of others is that there had to be an intention. I'll show you some of the artifacts. And it couldn't have just been accidental that somebody was just carving away at stone and then, oh, look, right? There had to have been intentionality. And this meant there had to be meaning through the symbolic representation and how they manipulated those materials, right? So language and consciousness had to have been necessary in order for symbolic representation to have taken place. Otherwise, it's all accidental. And that's highly unlikely, just given the amount, the sheer volume of artifacts that have been found. So I'm going to whip through these fairly quickly. Here's one of the oldest, 77,000 years ago, found at Blombus in South Africa. So intentionality is seen in a very kind of simplistic way, but things start to get pretty complicated about 32,000 years ago and between 39 and 40. So tons and tons and tons of shells, right, that have been perforated, that you know had been strung and worn for adornment of some point. This is a lion lady. This is like, and we can't just say, oh, I know what that means. No, you can't. We weren't there. We don't have a time machine. What we can say very carefully is there was some intentionality, some reason for somebody 32,000 years ago to want to have created that. And yet we don't see that 100,000 years ago. We certainly don't see it 3 million years ago. So we know something really interesting, what I call this kind of perfect storm, was coming together to allow our ancestors with their big new bulbous brains to start to more symbolically think about the world. A Venus from Dordogne, between about 25,000 BP, this means before present. One of the most famous Venuses, right, about 25,000 years ago. That's not hair, that's braided. They think that that's, again, an intentional meme that was done. And you got to think about things in a particular way as well. What we can also say, because we were the running ape, and we're seeing largely exaggerated features on women, like you can see the entire vulva here and large exaggerated breasts, it would have been quite novel for a woman to have been that size in a nomadic group, right? Because of the difficulty of moving around and whatnot. So that would have been highly valued, right, as kind of a luxury. So again, the exaggerated parts, right? The horse in Germany 26,000 years ago, and then the cave paintings from Kosker, around 28 to 29,000. Altamira in northern Spain. Here's Chauvet, and to me, this absolutely, every time I look at it, it just blows me away. Here's a rhinoceros down here, and these horses, and I remember the first time coming across this in my studies and just thinking, well, that's a fake, that's a fraud, right? Nobody 30,000 years ago could have been that good. Well, obviously, they were. I mean, it's been validated time and time again. And then the great Hall of Bulls in Lascaux. Now, here's the coevolution of language and consciousness. And here's why I think it's so important. Without the conscious ability to direct your actions, and without language to facilitate what it is you're conscious of, you're still stuck at a point at which you're living largely by instinct and specific patterns that can be recognized within a given environment. And for the largest period of time, that's all our ancestors needed in order to survive. We did not need consciousness to survive. We did need it to be here tonight. We did need it so you can hear my voice through this thing. Very, very important aspects in our evolutionary development. But what is it? Right? So here's a number of what I call, functional or operational definitions. So to be conscious, you have to be perceptually aware of your environment, but a lot of things are. A lot of things are perceptually aware of their environment. But we have self-awareness or meta-awareness, right? We know that we're within an ecological system and that we are also separate from it. And we can recognize the relationships between what we believe and how we can affect change in our ecology. And we can modify things in order to increase the likelihood to survive. We also have a strong sense of mortality. We are a very comparative group, and we use what's called analogical reasoning. So eventually people realized what death was and then personalized it to themselves. There are plenty of burial sites after 40,000, 35,000 years ago. There are hardly any before that. So clearly something was going on. Neanderthals, 100,000 years ago, just let their dead rot where they fell. There was nothing emotional, nothing sentimental at all. And that was just the way it was. And then we start to see burial sites, sometimes quite elaborate, with valued items like straightened mammoth tusks. Not an easy thing to do to straighten those. I don't even know how they did that, but obviously through heat. So I call this caveman angst, or the existential Cro-Magnon, the realization that that's going to be me someday. So there's a lot of symbolic representation. People were buried with stuff to help them, perhaps, on the journey into death. And then there's the theory of mind, what Robin Dunbar, now at Oxford, studies largely the ability to recognize where you stand within a particular group, and you can make inferences about the thoughts of others. So my son Jeremy and I are on the ASD spectrum, and we tend towards Asperger's. If you've ever watched The Big Bang Theory, and you know who Sheldon Cooper is, he has a great deal of difficulty making inferences about the thoughts of others. That's a major concern, sociality, with people with Asperger's. They just don't get it. But in order to survive, you need to know what that other person is thinking, right? Because you need to spot deception. It also allows for empathy. You see value systems and consciously directed self-improvement. Now you might be thinking, but there were a lot of screwed up beliefs probably back in the day. There were shaman, and they were throwing virgins into volcanoes and all that kind of stuff. The means themselves don't have to guarantee a group survival. They just have to have the appearance of doing that. And if enough people in the group think, good idea, chuck another virgin in, and that quieted the mountain king, then it lives, it survives. This is known as evolutionary epistemology. That belief gets selected to survive within a particular group. It could ultimately take out the entire group, right? If enough childbearing women get tossed into the volcano and you have none left, your group's got one generation to survive, and that's it for you. And that set of means has actually killed you or taken you out. So they don't have to guarantee survival. They just have to present the illusion of survival. So with a greater capacity for conscious awareness and more sophisticated languages, then there's a greater appreciation and whatnot, fear, reverence, whatnot, felt personally and eventually represented symbolically. Why do people have various types of religious beliefs? Because they think that God made this place for them. There's no way that could have occurred without consciousness and language. And so to get to this point, we went through a really unique period of human cognitive evolutionary development, which we're going to look at shortly. So now we have a heightened conscious understanding of our relationships. We have a reflective normativity of value. Chucking virgins in when the mountain is angry is a good thing. Knowing what's right and wrong or fair and unfair, however defined, came into being. They were trying to really understand three things within their world, right? Causality. Why do things occur the way they do? Morality. How should we behave within this particular group? And mortality, or understanding now that people die and that that's going to happen to me someday. So what I believe has happened is, out of this evolutionary period, this perfect storm of all of this stuff happening with language and consciousness, kind of feedback looping on each other, a number of things happened. These are, I guess we can call them rules of reasoning or bases of understanding that is used by species other than our own. And they don't have to consciously know what they are. But if they abide by these rules, it tends to promote their survival more. So the law of identity, or P equals P, this is essentially an equivalency. Something is what it is, and not something else. So a tiger is not a rabbit. If you think a tiger is a rabbit and you go out to pet it, nature teaches you something very, very quickly, right? So you violated that rule, your genes get taken out, you win the Darwin Award, and that's that. Right? The law of non-contradiction, it is not the case that you can have both P and not P at the same time, right? So nothing can be and not be at the same time. A fire cannot both cause heat and burn, and not cause heat and burn at the same time and in the same respect. Nature will teach you these lessons, sometimes very harsh, but they're unchanging. And the law of excluded middle, P or not P, something either is or is not. It's either raining or it's not. Well, it's missing. Is there water in here? Yeah, we'll call it rain. Okay. So it's either missing or it's not. And Aristotle was the one who identified these first, to stop the sophists from making it appear, from making the worst case seem better. Sound familiar? Trump. Does that? So Aristotle took it upon himself to stop the sophists. The sophists bragged that they could make the worst case. Give me a subject. I don't care. Any subject. By the end of tonight, I'll have you convinced. And they used pretzel logic. And people who were not trained in logic would go, could be? No! Aristotle said, no, it's not. They're making mistakes. And these are the foundational roots of all of logic. These are so basic that you can't really have an intelligent conversation without them. They are like Euclidean, right? They are like axioms of logic. They are so basic. And I've added a couple. So analogical reasoning, which I maintain is the oldest form of reasoning. It's just a comparative form of reasoning. So our ancestors are walking across the African savannah 70,000 years ago, and here comes 3 large cats. They're running at them, but they don't look like anything they've seen before. But they look big, and they look hungry, and they're running at us. What should we do? Well, if your analogical reasoning says they're similar to things that could kill us, maybe we might want to get up that tree. Then you do that, and you survive.